Greetings, grade 11s. Let us look at the second theorem in Euclidean geometry, which states that we have to know how to state the theorem. It states that the angle which an arc subtends, this angle, the angle which an arc subtends at the center of the circle is 2 times the angle it subtends at the circumference of the circle. So it's important to know the proof of this theorem, and also which axioms are required when you prove this theorem. So to start with, we need a construction. So you are required, okay, before you start, please read the statement. Given circle with center O, you are given a circle with center O, and then A, B, C lie on the circumference. It means they are concyclic. Then you are required to prove that AOB is 2 times ACB. Now, to start with, you need to construct. So you start by saying proof. We join. Now we want to form 2 triangles. So you say join OC and produce to any letter. We can say N, you can say B, so, and produce to N. So we are going to connect the 2 points. We're going to connect, then we produce to N. Then now we have 2 triangles. So I advise learners to start with either way, you can start with the first triangle or the second one. So I'm going to start with this one. In triangle OAC, I'm focusing on triangle OAC. So let us label 1 and 2, 1 and 2. In triangle OAC, what is happening in the triangle? Remember, the most important thing here in this theorem is that you must mention exterior angle. You must also mention equal radii, or end exterior angle of a triangle. It's very, very important. So I'm going to start by mentioning the exterior angle. O1 is equals to C1 plus A. If you can just look, we have something like this. This is O1, that is O1, that is C, that is A. If you can just turn it around, so O1 is equals to C plus A. That is the exterior angle. So you're going to say angle O1 is equals to angle C1 plus angle A. Now, reason exterior angle of a triangle. Then, from there, we can just say no. We have equal radii. We see what is happening here. Check here. In this triangle, this is equal to that. In other words, so it means if OC is equal to OA, therefore angle C1 is equal to A. Angle C1 is equal to angle A. Reason equal radii. OA is equal to OC, which is radii. Then there's something very important that you have to note in mathematics. I don't know if it's a postulate. Yes, it's a postulate. It's something that you must know mathematically. If A is equals to B and B is equals to A, and B is equals to C, because of the A is equals to B and B is equals to C, these two things are both equal to B. Therefore, A is equals to C. That is what you must know. It's very, very important. Then, what is really happening here is that also, I'm sorry about also, we can say A plus B is equals to C. But if A is equals to B, then we put this. If A is equals to B, it means that in replacement of A, we put a B. It means it's going to be B plus B, which is equals to C, which is 2B. 2B is equals to C. So it's very, very important to note that. So here it means C1 is equals to A. It means where we see A, we put C1. Therefore, you can say angle O1 is equals to angle C1 plus angle C1. Where we see A, we put in C1. Sorry. Then you've got C1 plus C1, which is 2C1. Therefore, angle O1 is equals to 2C1. So it's very important to note that. So we are getting somewhere. This is twice that angle. So we are getting somewhere. Then this is for one triangle. For that triangle, you don't have to prove again. So you can just say similarly. Similarly, in triangle what? In triangle OBC. In triangle OBC, the very same scenario. Angle O2 is equals to 2C2. Now we use this one. Angle O2 is equals to 2C2. Then you're going to add O1 and O2 because remember it forms AOB. AOB. So it's O1 plus O2. We combine it. So therefore angle O1 plus angle O2 is equals to, we also add the 2C1 and the 2C2. Then O1 plus O2 according to the RTP is AOB. AOB, it's O1 plus O2. Therefore, AOB is equal to 2 times. Now, common factor is C1 plus C2. The common factor is 2 there. Then C1 plus C2 is known to be ACB. Then AOB is equals to 2 times ACB. Then you have proven that the angle which an arc of a circle subtends at the center of the circle is twice the angle it subtends at the circumference. Remember that is a circumference. The angle at center is twice the angle at the circumference. So that is basically theorem number 2. Stay tuned for more theorems. We are going to prove cyclic quad. We are going to prove tan chord, and also the line from the center of the circle. Thank you.